When we're dealing with right angle triangles, we always use SOHCAHTOA. When we're dealing with non-right angle triangles, if they have a complete ratio, we can use the sine law. But if they don't have a complete ratio, so if it's something like this, where we're given, say, 10, 30, and 12, we call this side angle side. We need to use what's called the cosine law. That'll let us find this side length. And then we'd be able to use the sine law afterward because we'd create this complete ratio. The other case that we can use the cosine law is, again, when we're given enough information to solve some things. If we were given like 10, 12, 15, where we have no angles. So here we don't have any complete ratio at all. This would be another case where we could use the cosine law. Now, the cosine law states, so if we had A, B, C, okay, and again, we can make A, B, C. So same triangle. We don't know if this is 30 or not in this triangle, so we can't say that. But if we're looking at this, we're gonna have side A squared equals B squared plus C squared minus 2BC cos A. Now this is the side version. Okay, this is when we're finding a side length. This will always be given to you, okay? And we're always finding the side across from the angle we're given. Now the angle version, we'll find angle A, but you can change this for any value, okay? If you notice when you're looking at these, this angle A is the same as this A. Now B and C, it doesn't matter what order they're in, but they're attached here. It could be C squared plus B squared minus 2BC, because we're multiplying, it doesn't actually matter the order, okay? But that A, the angle, is always attached to the side we're solving for. Now, if we were to rearrange and try to solve for A, just the angle, we would get something like this. A equals the cos inverse of, we're gonna have B squared plus C squared minus A squared, all divided by 2BC. Okay, and this is the angle version. This is when we're solving for an angle. So sometimes I'm gonna just change it slightly because I feel like this would help us out a little bit. Sometimes it's easier to look at if we have cos A is equal to all of that. And then all we have to do at the end is take the cos inverse once we've solved for those values. So let's look at two examples. The first one, it says just find side B. Well, this is nice. It's set up that B is directly across from the angle. So this is exactly the cosine law. So we're going to use, in this case, B squared, because that's what we're solving for, equals A squared plus C squared, those are the other two variables, minus 2AC cos B, because that needs to match with that. So now we're going to start substituting everything in. We're going to have B squared. I'm just going to leave B squared equals. Now A is 52 squared plus 36 squared minus 2 times 52, times 36 times the cos of our angle, which is 42. Now, when you're putting this into your calculator, I find that it's helpful if we work back to front if you don't have a calculator where you can see everything. The other thing is you should definitely use brackets because you want to make sure when you're going through this. Now, 52 squared, I'm going to write down all these values. On my calculator, I start with cos 42, times it by 36, times it by 52, times it by negative 2. And then I get negative 2782, and it's about 0.3. I would then add 36 squared. So this is, I'm not taking anything out of my calculator, so I would add 1296. And then I would add 2704, which is 52 squared. Okay, after that, I'm gonna get B squared is gonna be equal to approximately 1217.7. And then that's gonna make B equal to about 34.9 meters. And I didn't round until I got to the very end. Now, I've written the rounding on the page, but I didn't round any of my values until the very end. I worked backwards so that I could keep just hitting plus and then squaring a value. It's just a little bit easier to enter it in. Okay, looking at this, we need to solve all the angles of the triangle. Solve the triangle means solve for everything. So I'm going to start with angle R just because it's on the left and I'm reading it left to right. So in this case, we're going to use cos R is equal to, and we've got b squared plus h squared minus r squared, all divided by 2bh. Well, that's going to be cos R is going to be equal to 15 squared plus 10 squared minus 16.5 squared, all divided by 2 times 15 times 10. Now, when you get your cos inverse of all of that value, you're going to end up finding that R is equal to, it's 79.8, I believe, but it should be around 80 degrees. Now, I'm going to do the exact same thing for B because I need to now solve for B, and I don't want to use sine in case I've made a mistake. So I'm going to do the exact same thing. So I'm going to have cos B equals, and it's going to be all of the same stuff. I'm just substituting in. So we're going to have, in this case, we're going to have 10 squared plus 16.5 squared minus 15 squared, all divided by 2 times 10 times 16.5. Whoops. And then we're going to take the cos inverse of all of that, and we'd find that B is equal to 63 degrees. And now to find angle H, we're going to just do angle H is equal to, so that's angle R. We've got that. We've got angle B. It's right there. H is going to be 180 minus 80 minus 63. So we know angle H is going to be equal to 37 degrees. And we've solved our triangle. Okay, we've used the cosine law twice. We've used both different versions. It's just a matter of rearranging and being careful when you substitute these into your